Respected Professor, thank you for giving me the opportunity to present the findings on predicting heart disease using three machine learning models. My work leverages the data set stored in Redis, aiming to develop models that can effectively predict heart disease based on various health indicators. So now I'll show you the connectivity between Redis and data loading. My database already exists, so this is my database. It has 100k rows and 8 columns. Also, my configuration, the password and everything is stored in the YAML file separately for ethical purposes. So, uh, this is my code where I have loaded my database into Redis successfully. Okay, so uh, upon analyzing the dataset and training initial machine learning models, we observe the following result. I have trained three. I first. I mean, I've data profiled my data set. I've cleaned it, so I found like zero missing values in the data set. Also, I have implemented three models. I've built three models, that is logistic regression classification model, random forest model, and gradient boosting model. Here the accuracy is relatively high, 91%. The random forest accuracy is 87%, and the gradient boosting accuracy is 91%. But if we see the accuracy of the yes classes for the recall and for the F1 score is very, very low. Also but for the random forest accuracy for yes is not bad, it's good, but for the gradient boosting classification the yes value is 0, which is not good, so we have to improve. And I've made changes for a better output for the logistic regression classification model and for gradient boosting. One of the challenge which I encountered was I mean when I trained my initial models, all the three models, was that there was a really huge data imbalance, uh, because the majority classes, that is the no class, they heavily outweighed the minority class yes. Yeah, as we see here. Yeah, they heavily outweighted the minority class yes. So to address this issue, we apply this mode technique, which oversamples the minority class to balance the data set. We employ the grid search cv to fine tune. I'll show you. We apply the grid search cv to fine tune. Here it is, the hyperparameters of our logistic regression and gradient boosting models. This optimization step was crucial in improving the model's performance and achieving better predictive accuracy. So the improved model outputs are for the best logistic regression model after tuning the output is yeah, so the accuracy has reduced to 72%. I mean, that's okay, but the yes, so for the yes, the accuracy has increased to 72% for recall and F1 for 31%, which is really good, which is better than the previous one. Also, for the gradient boosting model, the accuracy has from 91 it came to 73, but for yes, it has increased. I mean, first for yes, the precision recall and F1 score was 0. Now it has increased to 20, 16, and 31%. Yeah, that is after tuning. Okay, so also I have uh, after the after the first implementation, I had done the confusion metrics for gradient boosting. This is the confusion matrix for the logistic regression, and this is the confusion matrix for random forest. Okay, I've also visualize the gradient boosting feature importance for better understanding the features which are really important to predict the heart disease. Also for random forest, this BMI was the most important for implementing. So in conclusion, while we achieve notable improvements in our model's predictive capabilities, there's still room for enhancement, especially in addressing the data imbalance more effectively. So yeah, this is my final project. Thank you. Thank you so much, sir, for teaching this course in a really fun way. Also, being available whenever I emailed you with any doubts. Also thank you for clearing all the doubts whenever I had in the class regarding the assignments, projects, or anything, and also for teaching really cool tools like Neo4j, Redis, and many more. Thank you, thank you, sir.